Hello everybody, this is Mark Basher with GoEngineer. I'd like to thank you for joining me on today's webinar where I'm going to be going over some of the highlights from the recently concluded AMUG 2019 conference that recently happened in Chicago, Illinois. Some people commonly ask, what is AMUG? And AMUG is an acronym for the Additive Manufacturers User Group Meeting. It's a 5-day conference for users of industrial additive manufacturing equipment. During the 5 days, it's comprised of a lot of really interesting keynote presentation from high-profile users. There's a supplier exposition portion where 3D printing manufacturers and materials suppliers and software suppliers, etc., will kind of show off their latest and greatest products to the actual user base. There's some manufacturer and sponsor presentations, a lot of user presentations going over, highlighting how certain companies are using these technologies and for their benefit. There's research presentations going over the types of studies and research going on and surrounding additive manufacturing in universities and schools and other organizations. And then there's a lot of networking. Every day involves a breakfast, lunch, and dinner where people can have a chance to interact with fellow users of the equipment. This is a conference that's been going on since it started over 31 years ago. The entire conference is done through volunteer support and the support of the sponsors of the event. So there's no money making going on as far as the actual event itself goes. People often ask why AMUG conference as opposed to other industry events such as Rapid or 3D Print Expo or something like that. And really the focus with AMUG is users getting together with fellow users. In fact, that's a requirement to register or participate in the show. So there's no salespeople, there's no marketing people, there's no media people, there's no investors, anything like that. It's really focused on just the people operating the equipment on a daily basis. So great opportunity for people to learn new products, best practices, emerging applications, and actually talk directly with people who are doing these sort of things. There's a chance for customers to get engagement with the OEMs, whether there's features of the equipment that they don't like or there's features they would like to see added. It's a direct chance for the customers to communicate with the product managers and things like that that are really driving development at the OEMs. And then there's a lot of networking and interacting with other users, kind of getting the real world scoop without having to hear a marketing spin or a fluff or something like that. So a lot of opportunities at AMUG that don't exist with some of these other shows. First thing I think it makes sense to go over is the GoEngineer partner updates. So as you probably know, GoEngineer distributes the full line of Stratasys and desktop metal systems. First thing I kind of want to share is the 3 main updates that Stratasys released at this show. Stratasys usually does 2 annual product releases, so this is the half one 2019 product release. And the items that they have put to market are first and foremost the V650 Flex SL system. So this is Stratasys' first entrance into SL, which is pretty exciting for people like me that have been operating FDM and PolyJet for many years. SLA's never been something that I've gone hands-on with, so it's a great opportunity for me to learn some additional technology. I also think that this SL machine being released at this conference is a little ironic because AMUG originally started out as a specifically 3D Systems user group. And if you know, 3D Systems company was really built around their SLA product. So it's interesting to see that Stratasys used this event to release that new product. When I say it's a new product, I do want to temper that with the fact that Stratasys has their printing services division called Stratasys Direct Manufacturing. Stratasys Direct Manufacturing has actually been running these V650 Flex systems for about 4 years now to serve their printing services business. So this is not really a new product by any means as far as it not being tested. They've been operating, I think, about 8 or 10 of these systems for going on 4 to 5 years at this point. So they're very confident that this has reached maturity and is ready for prime time and something that the customer base will find useful. And some of the backstory as to how Stratasys Direct Manufacturing need this, they realized that there were certain flaws and certain limitations in the capabilities of the other manufacturers' equipment out there. And so they designed this machine to really work around those limitations and to provide a more versatile easy to use, easier to operate, maintain piece of equipment. The way they describe this V650 Flex SLA is the SLA system for SLA operators by SLA operators. I haven't gone hands-on yet. We've got some trainings coming up in the next month or two, so we'll see how true that ends up being, but very exciting nonetheless, and I think it's going to be well received into the marketplace for anybody who's operating SLA systems. Next is the new STRATASYS F120 FDM printer. If you know the Uprint line of printers, which was wildly successful over the last decade or so, has kind of been retired in that they're no longer selling that as a new product. So this really fills that niche in the lower end in terms of cost and build size for the STRATASYS FDM technology. What this machine is, although it looks like an entirely new box, it's really just an entirely new shell. And the entire motion control and XY gantry is really copied over from the F123 series printers. So the F170, the F270, and the F370. So it's a really proven mechanical system. It's just in a smaller box without the bottom half that allows it to be placed onto a benchtop. Some of the exciting things about this are that the materials come in 200 cubic inch spools. Or when I say spools, I actually should say windings that are in a box. So very long unattended runtime, should be a very low maintenance system, and they mentioned it's around $12,000 for the system. So cheaper than the Uprint ever was, bigger build envelope than the Uprint ever had at 10 by 10 by 10 inches, and it does ABS and ASA material in one system. So if you were ever on the fence of considering a Uprint in the last 1 to 2 years, I think you'll find that your patience has paid off in that the new F120 system offers a lot more at a lower price point than the Uprint was able to offer. The third announcement from STRATASYS is the new Pantone validated PolyJet colors. So as you know, the J750 system is a full color printer. It supports up to 6 different printing resins. So if those are cyan, magenta, yellow, black, white, clear, you can print in a full color printing solution. Until now, colors are always a little bit of a tricky thing as we talk about translating from RGB to CMYK to, other color formats. Sometimes translating colors, things can be lost in the original target that we start off with is not necessarily what we get. So STRATASYS has gone down this road working with Pantone to get essentially certain colors validated as, yes, the J750 printer can print 853C Pantone or insert whatever Pantone. So all in all, it's not every Pantone color because there are certain limitations in the colors we can produce, but there are about 2,000 colors that have been approved by Pantone as, yes, the J750 can produce these 2,000 Pantones. So we'll be very excited for maybe things like toy designers and different graphic design artists where capturing the real color is very important to increasing the product realism and should open up a lot of new doors and streamline things for people using those systems today. Next updates I want to share, Desktop Metal. If you're not aware, Desktop Metal is a newer startup company we have partnered with, and they've come to market with a MIM-based printer they call bound metal deposition. So think of an FDM printer in concept, but instead of depositing a thermoplastic, we're depositing a metal powder contained within a polymer binding matrix. Desktop Metal has announced their product over the past 18 months, but we're really starting to see some of the cool parts beginning to emerge from that. So this was just, I walked through their booth and took a picture of the parts that I thought were most interesting, including, so here we have a copper piece here where we actually have conformal cooling channels going right through the center of the copper part. I thought there's really no other way to do something like that in copper. So definitely exciting. Their 17.4 display was looking really good. So here we see this piston structure that's been actually optimized with a different lattice structure using their own live parts software. And there we see kind of a gear set that meshes together quite nice. It's been post-processed and polished and looks really good. The fit is really exquisite. Very exciting to see parts of that quality. And then on the right, we kind of have a gas atomizer and a different bracket that was post-processed in some sort of a mass finishing process and really achieved, I would say, that polished surface where the layer lines are almost invisible, and now we're looking like a machined and polished stainless steel part. They've come a long way over the last 18 months, and as a company, we at GoEngineer are really excited to see the applications that this is going to unlock for our customers and see the rapid development that this platform is going to bring to metals 3D printing. Next, I'm going to shift gears and talk about some of the really cool and neat models that I saw at the conference. If you're not familiar, there is a company called Laika. They recently produced the movie Missing Link. And all of their different characters, it's a stop motion animation. So they've also done Kubo and the Two Strings, Missing Link, Coraline. All of these movies are done using characters that they've actually printed on STRATASYS printers. The newest movie, Missing Link, you recognize probably this character here in the bottom left. That was printed on the STRATASYS J750. So there we see one of the gentlemen, Brian from Laika, who's really responsible for driving this. He was also a keynote presenter at one of the days. And really cool to see how they're using this technology to change the filmmaking process and bring some cool new entertainment for us to enjoy. This was another model. I just had to take a picture of it and throw it in here. I thought it was just exquisitely finished. This looked like something right off of the assembly line, ready to just drop into a vehicle. It was about a half scale. To give you an idea on size, the whole thing top to bottom is maybe 24 inches. This was done by C Ideas, which is a service bureau based out of the Midwest, but their specialty, in my observation over the years, tends to be the exquisite high-end finishing. Like, you see everything there plated, painted, finished. You can't tell one of those items is a 3D printed item, to the naked eye, unless you start taking it apart, I'm sure, and seeing on the inside. So that was just really blown away. It incorporates, I think, 6 different printing technologies. So really, really cool to see just complete models like that. Here is a model of a cutaway section of a pump. This was in the DSM Somos booth. So DSM Somos actually produces a whole line of SLA resins. So this will actually be the preferred resin material on the STRATASYS V650 Flex SLA printer. They have a whole bunch of variations and all that, and I'm coming up to speed, so I'm not an expert as far as which ones were used here, but I really liked this pump cutaway assembly just because you could see all of the bearings, the seals, the rotating assembly, the impeller, the channels that the water's flowing through, and then the whole thing was painted and the impeller was actually chrome plated, so just a really exquisite model, very well done, and impressed me, so we're talking about it here. The next one is a model from Ford and Eckhart, who is a company that makes assembly line equipment for a lot of the big automotive OEMs. And what you're seeing on this one is essentially the before and after for a fixture that they've essentially redesigned from traditional manufacturing on the left, where we see a lot of bracketry and welding and handles and such, to the printed version of this tool on the right. This tool itself is essentially holding a transmission case as an operator is loading it from dunnage trays to an automated machining cell and then back to the finished goods dunnage tray. What's interesting about it is that the original design weighed about 90 pounds. Because of all the bracketry and things on it, it was very difficult for the operator to see around the workpiece that they were moving. And it's rather expensive with a long lead time to produce. And by using a STRATASYS 900 MC and the Nylon 12 CF, which is a carbon-filled nylon, they were able to take that tool that was originally a $48,000, almost $50,000 tool, and turn it into something that's a little $10,000 or $11,000 tool. They got the weight down by maybe to one fifth of the original weight, and it provided, because it was more compact and lighter, it actually allowed the operator to see the workpiece a little bit more clearly. Things like this just really show how additive manufacturing is really revolutionizing the way that things are being done all around us. And even in ways, we might not be printing cars for everyday drivers at this point, but the fact that we're printing the tools to make the cars that we're driving is a good sign of, the growth in the industry and the direction that this is headed. Another Exquisite model, this comes from Velo 3D. These are a newer metal 3D printing startup company. As I understand it, I took these photos from the STRATASYS booth because STRATASYS Direct Manufacturing has invested into this technology, and it's something that they're bringing in-house as a service. As I understand, it's a DMLS process, but it's very unique in that it can handle self-supporting angles all the way down to 15 degrees, where typically we would see supports generating on a DMLS process after around 45 degrees. And what this means is we can do some really crazy and wild geometries without having support structures in there that we then need to think about removals. This picture here is kind of at the top left is a turbine blade, but these conformal channels going through the center. The part seemed very robust, very good surface finish, and the channels through the center were completely resolved, free of any debris, and seemed to be done very successfully. So I wanted to share that one. This part on the right I thought was interesting. It appears to be like a metal screen filter housing or something like that. But the walls running through there and from the center area out to the outer diameter and back, those are probably about, I would guess, 30 thousandths thick. So very, very thin structures. And as far as I could tell looking at that, there is no warping, there is no visible surface defects, so the quality on this was extremely high. Of course, they have the mesh connecting those together throughout in a couple places. That looked great too. So these were both really, really astonishing to see how far DMLS process has come, and exciting to see the emerging capabilities coming out of that process. STRATASYS Direct Manufacturing is operating these systems, I understand, as a service at this point. If you want to learn more, we could definitely engage you with someone over there to talk about the technology further. So next step in my presentation, I just want to highlight some of my favorite presentations that I was able to sit through. This one comes from Ford, and I just explain the relationship with Eckhart and Ford, and how they're using additive to redesign various different elements of the assembly line components. And this was another one of those. This one, I believe, was holding a piece as they inserted it, think of like a dash component or something like that, as they had to insert it into the vehicle. What's also interesting, so in addition to this being printed out of nylon 12 carbon fiber, which is known for its high stiffness to weight ratio, they actually use the live parts software to optimize the structure there to bring the weight down and maximize the stiffness to an allowable level. And you can kind of get a visual reference on the size here from that center bottom picture, where the gentleman holding it, this tool itself is probably about 4 to 5 feet tall and maybe 3 or 4 feet wide over the shape of the brackets. The Fortis 900 system has about a 3 foot by 2 foot by 3 foot build envelope, and this actually had to be chopped into 3 different parts in order to get it to build. So it's a cool demonstration. The geometry, something that looks so organic, good utilization of these optimization softwares in building functional fixtures that are displacing heavier metal fixtures of the past. Again, it's things like this that really get me excited to see the direction of the industry and the improvements coming and how people are utilizing it. Another presentation I sat in on that I found very useful and interesting was the Elite Additive presentation. Elite Additive is essentially a company that focuses in finishing solutions for additive manufacturing and automated solutions for additive manufacturing. Whether that's robotic cells to load new jobs and remove finished jobs from printers, whether that's cells that are then taking those finished parts and doing mass finishing and tumbling and essentially getting them ready for painting or just matching like an injection molded quality finish. The results there were, very astonishing. And although I haven't exactly seen the data firsthand, as I understand it, some of these finishing processes are what are called deformation processes. and we're mechanically deforming the surface in a way where we're actually increasing the part strength because you're, eliminating any of the surface defects, and you're essentially putting compressive stresses on the surface of the part, which then need to be overcame before you really start stressing the part out. So very interesting to see the development there, and really a good solution to take any additive manufactured part and essentially have it match the look, the finish of a more traditionally manufactured part. This next presentation I sat through, which was I thought was really interesting. This is kind of a soft spot for me because I think jigs and fixtures are the most obvious, lowest hanging fruit in the FDM space. The problem with jigs and fixtures is you have to design them all. So Ford and a company called Trinckle, which is a software company, have partnered together, and you kind of get the essence of it looking in this picture of the car in the top right, and we see all of the different areas where basic badgings and stickers and graphics and things like that get applied to the outside of the car, and you need a fixture for each one of these. Traditionally speaking, the concept of the fixture is very simple. The same elements, the overall thickness, the fact that we have handles and inserts for magnets, all of that is repeated over and over again for each one of these different fixture elements. So the problem is now when you have to do 20 or 30 fixtures, if you have to spend an hour of each one, that's very repetitive, time-consuming task for something that is essentially so simple. So Trinckle has come out with this automated design software that allows the engineers from Ford to bring in, whether it's a fender panel and a badge, the Focus logo or whatever it is, and they bring that into the software, and they essentially just quickly draw a boundary and then use like drag and drop features to add, okay, we want a handle here, we want a magnet here, we want an edge guide there, and literally in a minute or potentially seconds, we can go from CAD design on the vehicle to having a fixture designed. So really opening up a design bottleneck and allowing what took engineers hours or days before to design all the simple fixtures, this is now a task that can be done in minutes. Very exciting to see that software development and help drive the savings associated with going additive versus a traditional machined workflow or something like that. This one I thought was interesting. Heineken did a presentation, and I was really there for just the free samples. They didn't have any, unfortunately, but I like to see a really cool story along the way. And you don't think of Heineken as somebody who would use 3D printing. They make beer, and they bottle beer, and they distribute beer. So where does the 3D printing come into play? But if you think of Heineken, they're a global manufacturing company. They've got manufacturing plants, bottling plants, etc., or breweries, if you will, all over. And basically a lot of their brewery design and their bottling line design is really repeated at many of these different facilities. So there's some standardization, right? The parts that are used, they use over and over. And because of the criticality of keeping these lines up and running and the costs of a line going down, Heineken has these massive warehouses full of spare parts for all of their different apparatuses. And they started this initiative where instead of having these huge plants and having, factories that are down or lines that are down for weeks at a time as they're rushing to get through customs and get to sub-Saharan Africa to get the line back up and running again. What they're doing now is identifying the different components in their different lines that are 3D printable. And then once they validate, yes, we've redesigned it for printing, we've printed it, we've tested it, it works. At that point, they're able to basically just maintain a digital inventory of design files. Then they have this small 3D printing team at each of the various locations that are capable of reproducing that part on site, virtually on demand or in hours, instead of waiting days or weeks for parts to get packaged up, shipped through customs, and delivered to the end user location. So I thought this was really cool to see even how a brewing company, an alcoholic beverage company can be embracing 3D printing such that they've got multiple 3D printers at virtually every site of theirs globally. It really just shows, again, how the industry is evolving and working well beyond the original rapid prototyping type space that it was spawned out of. The last one I thought was really interesting was operationalizing 3D printed electronics. So this one was really focused on, printed circuitry, printed circuit elements. I took what was already a crazy slide set here and I put multiple of them on a page, so I hope I'm not driving you nuts with that. It was really cool to see some of the uses that 3D printing is being incorporated into creating smart weaponry, smart soldiers, smart battlefield equipment. If you think of, typical soldier, and I'm definitely going to butcher the number here, but they're carrying something like 120 pounds of gear out in the field. So anything we can do to get the weight of some of the gear down allows them to carry more bullets, more useful equipment with them when they're going out into these battlefield environments. But on the weaponry side, the capability to produce embedded circuits and, integrating electronics and energetics into the actual components themselves, putting capacitors and supercapacitors and conformal and flex batteries and energy harvesting devices in these things so that soldiers maybe don't have to carry a battery or, these components become lighter because they don't have traditional batteries inside them. Lots of different, smart munitions going in. And the reason I bring all this up, and I think this is so interesting, because it goes along nicely with, at GoEngineer, we are also a distributor of nano-dimension printers, which are, essentially 3D printed circuit boards and allow us to do non-planar and various different circuitry elements that would not be able to be produced on traditional PCB methods. I think that this presentation really highlighted and reaffirmed the usefulness in the marketplace for this product and sort of gives you some good ideas as to the ways and the potential ways that this technology can be ultimately used. One of our very good customers was at the show and has been a huge contributor to the AMUG organization, and that's Dinsmore Inc. So I just kind of wanted to highlight one of the really cool models. They have this, I think it was an Acura there that was very exquisite, painted, and if you if you took it out of the context and you were able to capture that on an empty environment, it would look like a real car. Other than the size reference items there in the business cards, those are the only things that allow you to see, how small this thing really is. Very good display, very cool utilization of the technology. And what I think is cool about a company like Dinsmore is how they're embracing all elements of the technology, where we have the STRATASYS, the HP, the carbon. They've really got their fingers on the pulse of all the different technologies, because at the end of the day, although there's some competition amongst 3D printing manufacturers, I really think that, they all have their own unique niche in situations where their product is the best. I think of all the different products out there, like planes, trains, cars, trucks, ships, boats, whatever, right? There's a certain reason you'd keep each of these different transportation methods. And although you could move a pallet on a train or in a truck, there's certain reasons why you might choose to use one over the other. And Dinsmore is a company that really understands this and really using the right technologies in the right ways for their customers and very knowledgeable in that. Some of the last things I want to cover as part of AMUG is a technical competition. This technical competition just really involves two categories, and the one that I'm highlighting here is the finishing competition. Essentially, it's taking something printed and making it look like something that is just off the charts in terms of realism. This year was a first where the technical competition was actually at a tie because both of the models were just so good. So you see kind of the Master Chief guy there walking in the sand, and this picture probably doesn't do it justice here. This thing looks like the real deal right out of the video game, even down to the sand looking like actual sand. On the right-hand side, you see a cello that was printed on a larger format system, fully finished and just really looked exquisite. And the level of artisticness to it I thought was really, really cool. The way you can't really see it in the picture again, but the way that paint on there reflects the light is amazing, and you couldn't see any of the layer lines on that thing at all. So the untrained eye, it would appear to be exact wood. So I thought that was really, really cool to see entered into the competition and win there. So that kind of wraps up my presentation for today. I hope you enjoyed some of the highlights from AMUG. If you're a user of the equipment, I would highly suggest that maybe you consider planning that for 2020. It's a great show. It's growing very rapidly, very useful, and hope to see you there next year. Have a great day, everybody. Please reach out with any questions, comments, anything like that. I would love to hear them from you. Thank you. Bye-bye.